Hi, welcome to another Level 2 algebra video. We turn our attention to exponential equations. Now, exponential equations involve exponents or indices. For example, 2 to the power of x is equal to 128. Well, we know 2 to the power of 7 is 128, so we know x is equal to the number 7. However, let's look at this equation. 3 to the power of x is equal to 100. Well, we know 3 to the power of 4 is 81, which is not quite enough. And 3 to the power of 5 is 243, and that's too much. So we know x is going to be somewhere between 4 and 5. It's a decimal somewhere between 4 and 5. Let's show you a really cool way of solving this. So let's get straight into example 1 and solve 3 to the power of x is equal to 100. All we're going to do is take the log of both sides. We're using log in base 10. Now, you know, whatever in equations, whatever we do to one side, we must do to the other. So I can take the log of one side and take the log of the other. Now, why are we using base 10? Because our calculator has a log button that's set up in base 10. Remember, when we say log in base 10, we just can write log without the base 10. People know it's in base 10. So I'm going to get rid of the base 10 and just say log of 3 to the power of x is equal to log of 100. Right, so now let's come back to one of our log rules we learned in the last video. The log of m to the power of n is the same as bringing the power of n out the front and timesing it by log of m. Well, we have log of 3 to the power of x. So we're going to take the x and bring it out the front and times the x by log of 3. So we're going to say x times log 3 is equal to log 100. Now we can divide both sides by log of 3. That cancels the log 3 on the left-hand side and leaves us just with x. And we're left with x is equal to log of 100 divided by log 3. So now I grab my calculator and go log 100 divided by log 3, and I get my answer of 4.19, and I've rounded that to 2 decimal places. We knew the answer was somewhere between 4 and 5. We've now worked out the exact answer. Cool, let's use the same idea for an application. Example 2, Jennifer's car, which she bought for $18,999, has continually depreciated, gone down in value each year at a rate of 11% each year. The value of the car is modeled by the function v is equal to a times, in brackets, 1 minus r over 100, all to the power of t. Now, a is the initial price, what it was when she bought it. R is the depreciation rate, that's the 11%, and T is the time in years. So our job is to determine how many years it will take until the value of the car is less than $10,000. So here's the first statement I've written down. A is $18,999, that's what she paid for it. The depreciation rate is 11%. Now, the bit inside the brackets, 1 minus 11 over 100, gives us 0.89. So we can say V is equal to 18,999 times 0.89 to the power of T. Now we want to know the value of the car when it gets down to $10,000. So we're going to replace that with 10,000. Okay, on both sides we're going to divide by 18,999 to get rid of the times 18,999. So the 18,999 will cancel, and we need to work out what 10,000 divided by 18,999 is, which is this decimal. Try and keep it as accurate as you can. The more accurate you can, the better your answer will be at the end. So this is equal to 0.89 to the power of t. Now we can use this trick with our log. So let's take the log of both sides, and let's use our log rule. This power of t can come out the front and times by the log of 0.89. And now we can divide both sides by log of 0.89. That'll cancel the log of 0.89 on the right-hand side, and we're going to be left with t is equal to log of that big decimal divided by log of 0.89, and we can grab our calculator and work out the answer to get t is equal to 5.51 years. So we've worked out that it's going to take 5.51 years to get down to a value of $10,000, and therefore anything greater than 5.51 years will be less than $10,000. Cool. Thanks so much for watching in on this video.